to True Projects. In this video, we are going to explain about a project titled Automated Machine Learning for COVID-19 Forecasting. In December 2019, an outbreak of coronavirus disease originating from severe acute respiratory syndrome coronavirus 2 emerged in Wuhan, China. As of January 2020, the World Health Organization urged the government to be prepared for active surveillance and effective case management strategy. The ability to accurately predict the disease propagation is vital for informed policy making. In response, numerous researchers have engaged in developing the forecasting technique using the available data, including the confirmed cases, fatalities, hospitalizations, and the vaccinations. Notably, organizations like European Centre for Disease Prevention and the Control have diligently compiled such data, which hold the significance in predicting the COVID-19 dynamics due to its direct link to the human mobility, a key factor in the disease transmission. Leveraging the AutoSK-Learn AutoML framework, we extend its application to predict the COVID-19 mortality data. Furthermore, we introduced two-level AutoML forecasting approach tailored for the multi-step ahead time series prediction. Our focus is on predicting the COVID-19 mortality through the lens of time series regression. We delve into the application of AutoML techniques to fulfill this objective, shedding light on its potential and this context. Our investigation encompasses the significance of the different data sets and tackle the challenge of accommodating the data drift, a phenomenon arising when the fundamental data generating the concept undergoes the alteration. A distinguishing aspect of our work is the temporal gap as we focus the COVID-19 outcome at a considerable later stage compared to the of initial research project. This temporal advantage enables us to harness the methods like deep learning which thrive on the larger training data availability, a luxury not afforded during the early stage of the pandemic. Our research involves adopting the widely recognized and accessible AutoML framework, AutoSK-Learn, for the intricate task of COVID-19 forecasting. Going beyond the framework's conventional application, our study aims to uncover the optimal utilization of the diverse disease and the mobility dataset, thereby refining the accuracy and the effectiveness of the COVID-19 prediction. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. In this step, essential libraries and packages are imported, and these packages provide the crucial tools and the functions that will be utilized throughout the project. And the second one is exploring the dataset. This phase involves a comprehensive analysis of the dataset containing of the COVID-19 related data. Data exploration helps in understanding the structure, distribution, and the characteristic of the dataset. Insights of the gained from this exploration guide. The next step is data pre-processing. Here, techniques are employed to clean and pre-process the dataset, this involving handling the missing values, outliers, and ensuring the data uniformity to enhance the quality of the subsequent analysis. And the next one is visualization using Seaborn and the Matplotlib. Data visualization libraries like Seaborn and the Matplotlib are utilized to create the informative visual representation of the dataset. These visualizations aid in understanding the pattern, trend, and the relationship within the data. And next one is label processing. For the supervised learning task, label processing involves preparing the target variable in the context of COVID-19 forecasting. This could entail the structuring, mortality data, and training and the prediction. And the next one is feature selection algorithm. Feature selection algorithms are applied to identify and retain the most relevant variable for the analysis. This step helps in improving the model efficiency and prevents the overfitting. And the next one is splitting the data into the training and the testing set. The data set is divided into the training and the testing subset. The training set is used to train the model, while the testing set is kept separate to evaluate the model performance on the unseen data. And the next one is building the model. Here, for the prediction, we use it of three algorithms that are linear regression. It is a fundamental predictive modeling technique, and this contest it aims to establish a linear relationship between the input variables and the target variables. The model learns the coefficient that best fit the data and predicts the future mortality based on the input feature. Its simplicity and the interpretability make it suitable for an initial understanding of the relationship between the features and the outcomes. And the second one is lasso regression. It is a variant of the linear regression, adds a regularization term to the model. This term penalizes the absolute value of the coefficient, encouraging the feature selection by forcing some coefficients to become exactly zero. And the COVID-19 project lasso regression could identify the most influential feature affecting the mortality rate, aiding in prioritizing the critical factor for the policy and the intervention decision. And the third one is SVM. SVM stands for Support Vector Mission, is a powerful classification and the regression technique. In COVID-19, in prediction is used for regression, modeling the relationship between the input features and the mortality outcome. SVM aims to find the hyperplane that best separates the data point, enabling the accurate prediction based on the element of the data point with the hyperplane. And the 5-time series forecast, we used exponential smoothing using ARIMA for forecast. Time series forecasting is crucial for predicting the future trend and the COVID-19 mortality. Exponential smoothing is a popular technique that assigns the exponentiality decreasing the weight of the past observation to make the future prediction. Autoregressive integrated moving average integrates the autoregressive and the moving average component, making it particularly suitable for handling the trend and seasonality in the time series data. Applying the exponential smoothing using ARIMA to project allows for the accurate prediction of the COVID-19 mortality rate over the time, aiding the policymakers and the healthcare professionals in anticipating the healthcare needs. And the next step is user gives the input. A user interface is implemented using the Flash, allowing the user to input the relevant information for the prediction for the forecasting. And the next step is the given input is pre-processed for prediction. The user provided input is pre-processed to align with the model requirement. This ensures that the input is properly formatted for the prediction process. And the next one is trained model is used for the prediction. The trained model, whether it's for prediction using the linear regression, lasso regression, SVM, or with the ARIMA, is employed to make the prediction based on the pre-processed input. And the last one is final outcome is displayed. The prediction forecasted outcome is presented to the user. This involves displaying the COVID-19 mortality estimates the future trend, providing the valuable insight into the pandemic potential trajectory. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The algorithms folder containing of various py files which contain the algorithms within it. And the dataset folder containing of the dataset that we used in this project. And the static folder containing of the folders like of assets, CSS, JavaScript files within it. And the template folder containing of the HTML documents. It typically includes the about, index, notebook, results, sign in and sign up pages within it. And the test folder containing of the templates and app.py file within it. An app.py file is used to containing of the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model files contain the information of the algorithm and is loaded into the project code during the runtime to execute the various tasks such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command, that is python space app.py. By using this command, it will execute the Python script and perform the runtime checks for any syntax errors or the logical issues within it. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to this page containing of the information and the title of the project. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of username and password, and we need to fill those details and then click on the login button. Here it will redirect to the index file containing of some input details that are need to be filled to predict whether for the COVID forecast. And I'm clicking off the cough. By we need to choose a level that is having the cough or not. By that I am clicking as fever as, sore throat as, shortness of breath as, and headache as, and age 60 and above no, and gender female, and test indication contact with confirm. And then click on the predict button. Here it will predict the outcome as of result positive based on the ML. And by clicking on the prediction button, here we read it back to this index file, and here we can enter the other details. Cough as of no, fever no, sore throat no, shortness of breath no, headache yes, and the age 60 and above no, and the gender is male, and the test indication is of other. And then click on the predict button. Here it will result as of positive based on the ML. In this way we can test the COVID-19 by using this input feature. And in conclusion, we have evaluated the performance of our ensemble based on the root mean square errors compared to the 5 different baselines found in the recent COVID-19 forecasting literature. Overall, our work has demonstrated the potential of devising the AutoML solution for the COVID-19 forecasting, as well as using open mobility data to guide the prediction. Our experiments have shown that it is possible to increase the forecasting accuracy by using the mobility feature in addition to the molality rate. Our experimental result also suggests that the place visits the mobility data is more informative than the mode of the transformative mobility data. This due to the fact that the place visits the data is less aggregated as opposed to mode of transport set.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.